Welcome back again to another episode on Joktan Online Maths. Today we have a question on the board which we are going to look at. The question says 8 raised to the power of x plus 27 raised to the power of x all over 12 raised to the power of x plus 18 raised to the power of x is equal to 7 over 6. This question is under indices. It's an initial question which we are going to solve. Now I'm going to teach you a method which maybe probably some of you have not seen before. Now let us see. First, before we solve this, let us do cross multiplication. This multiplies everything here. 6 multiplied by 8 raised to the power of x plus 27 raised to the power of x equal to 7 multiplying everything in this 12 raised to the power of x plus 18 raised to the power of x. This is the first step. Now let us distribute these numbers outside. So this becomes 6 multiplied by 8 raised to the power of x plus 6 multiplied by 27 raised to the power of x equal to 7 multiplied by 12 raised to the power of x plus 7 multiplied by 18 raised to the power of x. Now, if we read this point, there is something that we can do. Now, if you observe, all these numbers are all having powers of x. Now, we are going to take the one that has the largest base, which is 27, and divide it through. There is a reason for that. You will see it later. Now, dividing it through by 27 raised to the power of x. We divide through by 27 raised to the power of x. 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 Now, all these things that we have done now is just the same thing as dividing both sides by 27 raised to the power of x. Now, that is why I have to split it for us to see what it means. So, this can be written as 6 open bracket 8 over 27 all raised to the power of x, since all of them are having powers of x. And likewise, this can be written as 6 multiplied by 27 over 27 all raised to the power of x, and is equal to 7 multiplying 12 over 27 all raised to the power of x plus 7 multiplying 18 over 27 all raised to the power of x. As we know, this is the same thing as 1. So therefore, how can we reduce this? We can reduce them in this way. We know that 8 is the same thing as 2 raised to the power of 3, while 27 is the same thing as 3 raised to the power of 3. So this can be written as 6 multiplying 2 raised to the power of 3 all over 3 raised to the power of 3 all raised to the power of x plus 6 equal to 7 multiplying. Now how can we do about this? We say 3 into this is 4. And 4 is the same thing as 4 raised to the power of 2 raised to the power of 2. While 3 into 27 is 9, and 9 is the same thing as 3 raised to the power of 2. All raised to the power of x plus. This 3 can go into this 6 times, and 3 can go into this 9 times. So we can say this is to be 6 over 9 all raised to the power of x. And also 3 can go into them. 3 can go into this 2 times, and 3 can go into this 3 times. So we have 2 over 3 all raised to the power of x. Now if you observe something, this can also be written as 2 over 3 all raised to the power of 3x plus 6 equal to, likewise this 2 over 3 all raised to the power of 2x plus 7 multiplying 2 over 3 all raised to the power of x. If you observe, all of them have common argument in the parentheses. 2 over 3, 2 over 3, and 2 over 3. So we can let a certain alphabet or anything to be equal to 2 over 3 all raised to the power of x. So I would like to choose, let p be equal to 2 over 3 all raised to the power of x. Now we are going to substitute the value of p equal to 2 raised to the power of x, 2 over 3 raised to the power of x in this equation. And let us see how it will be. From the left hand side, 6 multiplied by 2 over 3 all raised to the power of 3x is the same thing as p raised to the power of 3 plus 6 equal to 7 p raised to the power of 2 plus 7 multiplied by p So, this is a polynomial of degree 3. So this can be also rearranged as 6p raised to the power of 3 minus 7p squared minus 7p plus 6 equal to 0. So we're going to solve this and get the value of p. Now, before we can solve this, we use trial and error. We need to find a value of p such that if we put it or substitute it here, we're going to get 0. So what value of p are we going to use? Now, if we use 1, if we and let's say using trial and error, if we use p to be equal to 1, what will happen to this? This implies that 6 1 raised to the power of 3 minus 7 1 raised to the power of 2 minus 7 1 plus 6. Is it equal to 0? Let us see. 6 1 raised to the power of 3 is 1 and 6 is 6. So we have 6 minus the same thing, 7 minus 7 plus 6. Is this equal to 0? This is not equal to 0. So we cannot use p equal to 1. Let us try p equal to minus 1. If you put minus 1 here, what will happen? This is 6 minus 1 raised to the power of 3 minus 7 minus 1 all squared minus 7 minus 1 plus 6. What will happen to this? This is the same thing as minus 6, and this is the same thing as minus 7, and this is plus 7 plus 6. Minus 6 plus 6 is 0. Minus 7 plus 7 is 0. So everything is 0. So that means the value of p that will make this equation 0 is minus 1. Now we have gotten one of the roots of this equation. At p equal to minus 1, this equation is 2. So this also can be written as p plus 1 equal to 0. So we are going to use this, since we got one of the roots, we're going to use this to factorize it from the equation start using long division. P plus 1, 6p raised to the power of 3 minus 7p squared minus 7p plus 6. So we're going to use this in order to get the remaining 2 roots. Now, p into 6p raised to the power of 3 is the same thing as 6p squared. Now, we use this to multiply 6p squared multiplied by p is the same thing as 6p raised to the power of 3 plus 6p squared multiplied by 1 is the same thing as 6p squared. So what we do is subtract. Subtracting this and this becomes 0. 7p squared minus plus 7p squared is the same thing as minus 13p squared. Now, the rest we bring them down. Minus 7p plus 6. Again, p into minus 13p squared is the same thing as minus 13p. So minus 13p multiplied by p, we have minus 13p squared. Then minus 13p multiplied by 1, we have minus 13p. The next thing we subtract again. Minus 13p squared plus, minus and minus becomes plus. So minus 13p squared plus 13p squared here is 0. Now, what about this? Minus 7p plus 13p, 6p. And this is the same thing as plus 6. Again, p into 6p is the same thing as plus 6. And 6 multiplied by p is 6p. 6 multiplied by 1 is the same thing as 6. Now we subtract. You understand that we have 0 and 0, no remainder. That means the remainder is 0. So since one of the root is p plus 1, the other root will be 6p squared minus 13p plus 6. Now we have to solve this quadratic equation again in order to get the 3 solutions, or the 3 possible values of p. Now, how to solve this? We just go by our normal conventional factorization method. 6 multiplied by 6, we know it is 36 p squared. 36 p squared. So we need 2 factors of 36 such that when we add it, we're going to have minus 13. Minus 13. So what are those 2 factors of 36 that when we add, we're going to have minus 13? Of this, we have minus 4p and minus 9p. When you multiply this together, you have minus 36p, and when you add it together, you have minus 13p. So let's substitute it here. So 6p squared minus 4p, or rather minus 9p minus 4p plus 6. How do we solve this? You know, all is also equal to 0. Now, how do we get this? Let's try and factor out something. You know, this is 6p and this is 9p. What are the common terms there? It's 3p. So 3p into this, we have 2p minus, when 3 enters 3, we have 3. And here we have, the common terms here are minus 2. So let's use minus 2. Minus 2 into this is 2p minus 3 equal to 0. So therefore, we have 3p minus 2 and 2p minus 3 equal to 0 as the other two roots of this equation. So therefore, we know we have p minus 1, multiplying everything here, 3p minus 2 and 2p minus 3 to be equal to 0. That implies that p is equal to 1, or rather, p is equal to minus 1. Then we also have 3p minus 2 equal to 0, or 2p minus 3 equal to 0. So here, from here, we know that we can collect the like terms, 3p equal to 2. And dividing both sides by 3, p is also equal to 2 over 3. Or from here, we know that p is also equal to 3 over 2. So these are the three possible values of p that can get us the value of x that we're looking for. But remember, we say p is equal to 2 over 3 all raised to the power of x. So how do we solve this? Now, I would like to start with these two values. We know for the first case, case 1, at p equal to 2 over 3, what happened to this value? It's also the same thing as 2 over 3 all raised to the power of x. And this is the same thing as raised to the power of 1. The bases are the same, you equate the powers. This implies that x is equal to 1 for the first case. Also, for case 2, at p equal to 3 over 2, what happened to when p is equal to 2 over 3 all raised to the power of x? Now, if we observe something, this number here and this number here are just reciprocal of each other. So that means the value of p here is the same thing as the reciprocal of p here. So we can say this is p inverse to be equal to 2 over 3. Or you can also write it as p here to be equal to all 1, or rather 2 over 3 all raised to the power of minus 1. Now we can equate them so that this will be equal to 2 over 3 all raised to the power of x. Now the bases are the same. X is also equal to minus 1. That is for the second case. 3. We know that there is a value of p we got to be minus 1. Now, how can we make it to be when p is 2 over 3 all raised to the power of x? Now, if these are equal, this implies that 2 over 3 all raised to the power of x is the same thing as minus 1. And we can relate this to log reading, that the log of minus 1 to base 2 over 3 is equal to x. But this solution is undefined. So the only solution for x that can satisfy that equation is x equal to minus 1 and 1. Hence the solution for this equation. Very beautiful and simple. Don't forget to subscribe to my YouTube channel for more videos or more exciting videos on mathematics. Have a nice day.